Now let's move on for the equation of bending moment in the distance from 0 to 3. So now we here, since this is the point where we are determining the bending moment, so now moment would be equal to, and I usually consider the clockwise movements as positive. So moment due to this 300 Newton force will be 300 multiplied by x, since we are calculating the moment at this point at x distance. How about the others? There is a triangular force and its direction is downward, so it will be negative. But how we are going to calculate this? So previously we have calculated that over here we have 100x Newton per meter. So this is actually 100x Newton per meter. So this triangular force will be calculated as 100x. The vertical side, the horizontal side is x, which is whole divided by 2. This is now the force, but where it's going to act, I mean the momentum. So it will be acting at x by 3 from this point. So multiply by x by 3 then. When you're going to solve this equation, you're going to get 300x. This will be 50. So 50 x cubed divided by 3. So this is the equation of moment at a distance x from the left hand side. Now let's draw the bending moment for this portion 0 to 3 portion. So when we put x is equal to 0 in this equation of moment, we are going to get moment as 0, and previously we have determined the point where we are having a zero shear force, which was under root 6. So this will be the point where we are going to have maximum bending moment. So when we put this value, so we are going to get 489.9 Newton meter as the bending moment. So at 0 value of x, the bending moment is 0, but as soon as we are reaching at under 6 distance away from the left hand, we are going to have a maximum bending moment. So bending moment is increasing up to a point where it reaches x distance. So let's say that's the not the x distance but under root 6. So this is under root 6 meters. So at this point we are having a maximum bending moment, which is 489.9 Newton meter. And if we want to determine the bending moment at 3, we just simply put the value of moment x value in this equation as 3. So at x is equal to 3, moment will be 450 Newton meter. So this point somewhere over here, we have a bending moment of 450 Newton meter, and this point is 3 meter. Now let's move on for the distance from 3 to 4.5, the last distance. Now we are in this portion. We just surpassed this 300 Newton meter and we are on this portion now, and we are having the same x distance from the left hand side. Since this beam is in equilibrium, we can take the left hand side or the right hand side. The calculations would be equal. So in order to have the less complexity in the calculations, we are not going to take the left hand portion because it will involve the triangular load and then a trapezoidal load. So calculation of that will be very difficult. So in order to make it simpler, we are taking the right hand portion of this beam. So to consider the right hand portion of this beam, we should be knowing the distance, I mean this distance. Since the total length of the beam is 4.5 meter, so then this distance will be 4.5 meter minus x. Now let's consider this portion and start doing the calculations on this. Before we start calculations for shear force and bending moment, we should know this magnitude. This should be known to us so that we can further move. So for that, again, we have to consider the triangles that we have considered before. This is the red one is a big triangle and the blue one is the small triangle. So if you know the basics is like the bigger one has an magnitude of 300 at a distance of 1.5 meter, and the smaller one have a horizontal distance of 4.5 minus x. So we actually want this distance. So the slope would be same. Slope of bigger triangle will be 300 divided by 1.5. Then in case of smaller would be unknown divided by 4.5 minus x. So from here we can determine this unknown. So let's simplify the calculations. So this unknown would be equal to 200 multiplied by 4.5 minus x. So this one is actually 200 multiplied by 4.5 minus x, or if you want to simplify, then again you can simplify this as well. This will be 900 minus 200x. It's up to you whether you take 200 4.5 minus x or 900 minus 200x. Now let's move on for our calculations, where we required this magnitude which we have just determined, that is 900 minus 200x Newton per meter. Now first of all we will determine the equation for shear force in this distance. So while determining the shear force at this point, we have to keep a few things in our mind. One important thing that we have to keep in our mind, that is, while we are determining the right hand side of the beam, we should take the opposite reactions in order to have the balance between the left hand side and the right hand side. So I mean, the directions that we were taking in the left hand portion was as like upward forces was positive and the downward forces was negative. But in this case it will be like, if it is upward force it will be negative, and if it is downward force then that will be positive. That's because in order to have the equilibrium between the right hand portion and the left hand portion. So 375 Newton force is upward, hence negative, and there will be positive shear force caused by this triangular load. And if you calculate this load, that will be 2 multiplied by 900 minus 200x. This whole is multiplied with the distance, which is 4.5 minus x. So from here we have a equation of shear force for the distance from 3 to 4.5. That equation is minus 375 plus 100 4.5 minus x whole square. This was done by taking the 200 common from this equation, or you just keep this equation the same that I told you before, as 200 in bracket 4.5 minus x. So that will be then in this equation, this form of the equation. Now for drawing the shear force diagram, this is what we have from our previous calculations that we did for the distance from 0 to 3 meter. Now we are moving forward for the calculation from 3 to 4.5. So if you put 3 in this equation, we are going to get the same value of 150. And if you put the value of x is equal to 4.5 in this equation, you are going to get the value of shear force as this. This term will be 0 because we are putting the value of x as 4.5. 4.5 and 4.5 will become 0, and as a result this term will be 0. So we are only being left with 375. So at 4.5 distance, if you were here, we have magnitude of shear force as 375. So this is the shear force diagram for this simply supported beam for being applied with the two triangular forces. Now let's move on for the determination of the equation for bending moment for this portion. So bending moment at distance of 4.5 minus x meter on the right hand side would be equal to, so previously I was considering the clockwise movements as positive in the left hand portion, but now as I told that when we are dealing with the right hand portion, then we have to take the opposites. Like in this case, you can see this 375 Newton force will be having a anti-clockwise movement around the x cross section. So anti-clockwise will be positive, so 375 will have a positive movement. The moment arm will be 4.5 minus x, and this triangular load will be having a clockwise movement, hence negative, and its magnitude will be, first you need to determine the force, which is of, let's make it simple like the when we did for the shear force, like 4.5x. This is the load. Now moment arm will be, if we are targeting the force will be acting here, so it will be 1 by 3 from the x, again 4.5 minus x, again the distance, divided by 3. So as a whole we have a equation of moment for the portion from 3 to 4.5 is 375 4.5 minus x. This term will remain same, but we can simplify this term. This will become 100 and divide by 3, and this 3 will be 4.5 minus x cube. Now let's move on for the drawing the bending moment. So this is what we have previously, and if we put the value of 3 in this equation, we are going to get the same bending moment. But if you are going to put the value of 4.5, then you can see this term will become 0 and this term will also becomes 0. So then the bending moment will be something like this. It will obviously be curvature of 3 degree varying in this way. So this will be 4.5 meter away. So this is how the calculations for the bending moment is done. We have derived the equation for the bending moment first, and then simply putting the value of x, let's say at 3, you're going to get the same value, 4.450 Newton meter. And if you are going to put the value of x is equal to 4.5, you are going to get the moment as 0. So this is how the calculations will be done for this kind of a problem, where we are being asked to express the shear and the moment in terms of x for both the portions from 0 to 3 and 3 to 4.5, and also we are asked to draw the shear force and bending moment diagrams. So that's what we have done so far. I believe you have an understanding of how this kind of problem is being solved. If there's still a doubt or something that you are not catching with up, then please let me know through the comment section so that I can get back to you. So that's all from this video. Thank you for watching this video, and I hope to see you in next coming videos. Till then, bye.